We're going to graph the following absolute value function. And the reason we're doing this function is to practice with the transformations. So this graph has a basic shape, and that basic shape is sort of a V shape, and that's situated at 0, 0 if the function didn't have any transformations. So here's the graph of the absolute value of x. But we're going to do the following transformations on it. The negative sign right here makes the graph flip over so that instead of facing upward, it's going to face downward. The 2 right here makes the graph stretch. So what that's going to do is make the V a little bit skinnier. So I'll sort of exaggerate it right here. And I don't know, somehow skinny makes more sense than stretch, but that's not a real formal word. And then the +3 right here has the action of moving the graph left 3, and this transformation is an up 4. So let's scoot this down a little bit so we can keep it on the screen. Okay, here we go. Oops. Let's erase that and make it white. Okay. So the vertex on an untransformed graph was right here. But we have to move our graph left 3 and up 4. So when I do that, I go left 3, up 4, and that's the new vertex. We know the graph is going to be V-shaped and sort of skinny like that. So to figure out some points on this graph, let's make a t-chart. So let's rewrite our function down here. F of x equals -2 absolute value of x plus 3 plus 4. Now, we make a t-chart. We want to pick points that are around -3 because we know that's going to be the center of that V shape. So let's pick -2, and then we'll pick -4 because those are equidistant from the center. The center is right here. Then let's pick -1 and -5. So when we plug the value -2 in right here, we're going to get a value out of 2. When we plug -4 in, it's also going to give us a 2. I'm not showing the work for that, but you can go through and do the computation. When we plug in -1, we get out 0, as we do when we plug in -5. So I plot those points on my graph. I have -2, 2, -4, 2, -1, 0, and -5, 0. So I connect those points and I see that's the function. Domain, it goes all the way to the left and all the way to the right. And range, on the range you do the smallest value first. So the smallest value on the y's is right here. How far down does this graph go? It goes all the way down to -infinity. And then you consider how far up the graph goes. So you're looking here, how far up, and you see it has an upper bound of 4. So that's how the maximum y value. And the graph does touch a 4. It's at, we know, -3, 4, so that's the highest point. And that's the domain and range of this function.